All right, so we're going to start talking about equilibrium and solving some equilibrium problems. So what do we know about equilibrium? Well, when something is in equilibrium, all of the forces cancel each other out. So that means that all of the up forces cancel the down forces, all the left forces cancel the right forces. There's no net force acting on the object, okay? If there's no net force acting on the object, there's no acceleration. That means it's at rest or moving at a constant velocity. This is the one that students often overlook, okay? Just because you're not accelerating doesn't mean you're not moving. You might be moving, you're just not speeding up, slowing down, or changing direction. You're moving at a constant velocity. So be a little careful with that part. Okay. Now, when we go to start solving some of these force problems, got some tips for you. First, draw a free body diagram. When you go through there, gravitational force or weight is almost always present, okay? We're typically on or near Earth's surface. If it is on a surface, then there's a normal force and there's a frictional force parallel to the surface that's opposite direction being pushed or moved. It's either static if the object's not moving, or kinetic if the object is moving. Letter C, if there's a string, rope, etc., then you've got a tension force, and the applied forces are given to you. So the step 1 is to draw a diagram. Step 2, write down your givens. Step 3, write down what you're trying to find. Step 4, write down the equations. Okay. If you are in equilibrium, then we know that the net force is 0. Okay, you're either moving at a constant velocity or at rest, and the up forces equal the down forces, the left forces equal the right forces, so everything cancels out. The net force is 0. If you're not in equilibrium, then we've got this equation down here, which we will look at in the future. Today we're going to deal with equilibrium. So let's take a look at our problem. It says, a museum curator moves a 140 kilogram aluminum sculpture across a horizontal platform. It takes a force greater than 870 newtons to move the sculpture. What is the coefficient of static friction between aluminum and steel? Okay, it's an aluminum sculpture, and this is a steel table that they're moving it along. Okay, so we're going to look at part A in this video. Next video we'll look at part B. So, going back and looking at our hints. Step 1, draw a free body diagram. So that is what we are going to do. Well, I'm just going to put a little dot here to represent the statue. Okay. If we look at our various forces, gravitational force is almost always present. In this case it is because we are near Earth's surface. So we've got a gravitational force. Okay. It is setting on top of a horizontal platform, so there is a normal force that is perpendicular to the horizontal platform, which would be vertical. So we've got a normal force. It says that it takes a force greater than 870 newtons to move the sculpture. So we're going to apply a force of 870 newtons to the sculpture. So we've got an applied force. However, that force is not great enough to move the sculpture. So the sculpture is not moving, which means that the frictional force is static friction. Okay, because it's not yet moving. We're not applying enough force to get it going. All right, so we've got our free body diagram. Next, it says, write down your givens. Okay, so my givens, well, 145 kilograms. Kilograms is our unit for mass. So we know the mass of the sculpture is 145 kilograms. We know it takes a force greater than 870 to move the sculpture, okay? So it's not going to be moving. We're still going to apply this force. So our applied force is 870 newtons. It says, what is the coefficient of static friction between aluminum and steel? And that is our next step to write down what we're trying to find. So the coefficient of static friction, we are trying to find mu sub s. That's the coefficient of friction, and this means static. So that's what we're trying to find. Then we're supposed to write down our equations. Well, are we in equilibrium? Yes. Then we know these equations. Okay? The sum of the force in the x is 0. The sum of the force of y is 0. So the net force in the x direction is equal to 0. The net force in the y direction is equal to 0. So we know these two equations. Now, these equations just have to do with forces, which is excellent, but this is not a force. So if I look at my equations, the only equation that has the coefficient of static friction in it is this equation. The force of static friction is equal to the coefficient of static friction multiplied by the normal force. So I'm going to need to use this equation eventually. But if we look at it, we don't know this yet. We don't know the force of static friction, and we don't know the normal force. The only force we have over here is an applied force. So we're going to need to find some things. So we'll look at these equations that we know because the statue is in equilibrium. Okay? So let's look at the first one. This means the net force in the x direction. If we add up all the forces in the x direction, they add up to 0. So let's add them up. Well, we've got the force of static friction in the x direction. And in my diagram, I have that pointing to the left, so I'm going to put a negative in front because we often say left is negative, plus the applied force. And in my diagram, that's going to the right, so I'll say it is positive. Those two forces will add up to 0. Well, I look over here. I do know the applied force, so I could substitute it in. So when I do that, subtract 870 from both sides, divide by -1. The force of static friction is 870 newtons. Okay, so now we know one part. Okay, let's substitute it up here. Hopefully, this equation will get us our other part. So let's take a look at it. Well, this net force, the sum of the forces in the y direction, so I look in the y direction, I have the gravitational force going down, and again, down we let be negative, so the gravitational force plus the normal force going up, so that'll be positive, they add up to 0. Look over here at my givens, I don't have either. Go back and look at my equation sheet. Okay, I have an equation that has gravitational force. The gravitational force is equal to the mass times the gravitational field constant. So I'm going to go ahead and use this equation. The gravitational force equals the mass, which we know is 145 kilograms, times 9.81 newtons per kilogram. And we get a gravitational force of 1,422 and 45 newtons. So now I can substitute that in over here. Well, it's pointing down, so I'm going to make it negative. So negative 1,422 and 45 plus the normal force is equal to 0. Add that to both sides. Our normal force is equal to 1,422 and 45 newtons. And now we have all of the variables in our equation except the one we are trying to find, so we can substitute in there. So I'm going to substitute in 870 for my force of static friction. We do not know the coefficient of static friction, and I will substitute in 1,422 and 45 for my normal force. Divide both sides by 1,422 and 45 And our coefficient of static friction is 0.61. And there are no units for the coefficient of static friction. That's because we just took newtons and divided by newtons, so the newtons canceled out. This is just a coefficient. It does not have any units.